Okay, this is part 2. I'm going to pick up where I left off in Russia. And this river bottom has a very nice corrugated ripple path along most of its length. Let's get a wavelength measurement here. 1.1. And then we have these sediment lobes here, perfectly shaped. And these, what I think are corrugated ripple patterns, are perfectly perpendicular to this feature here, which helps to validate my interpretation of this erosion. Okay. And then we've got all of these nice circular scabs. Let's keep going. Now look at this here. We can kind of see the river channel, it's bank to bank from here to here, 35 miles. It's very straight, which indicates a fast flow. And perfectly perpendicular to that is this ripple pattern here that's corrugated. So let's get a measurement on that. 1 mile exactly. And we also get these rectangular shaped scours, where you can see this is the scarp edge here. And the river today runs straight through there. And this river came through here, kept going. Let's check out this spot. Oh, this spot's really cool. What is that? Looks like little ripples in here. And some nice scarp edges on these lakes, which help us identify current direction. And if we keep going, it leads into a massive fluvial fan deposit, which this all formed underwater, since it's such a shallow formation, and it's 116 miles wide. So that's quite a bit of deposition. And then we've got some more scours over here. Pretty impressive landscape. Okay, let's go to the next spot. This is Kazakhstan. This is the Caspian Sea. If we zoom in, we should find some interesting features. We notice same type of scouring formation. These are all salt pans, right? The Caspian Sea is very salty. And these are salt-filled erosion paths, just like what we find around a lot of the world. And these features here are actually drumlins. They kind of look like ripples, but you can tell that they are orientated from this direction. They're kind of streamlined, right? Streamlined like this. You can see the river path. Excuse me. Over here we find some more ripples, drumlins, because they're streamlined. Very slightly streamlined, but you can still tell. And so these are all scablands, scoured out regions. These are all scours as well. This is quite an amazing feature here. And if we look at this, let's try to interpret its direction. We see that this is like a river that came across here. And we see these look like sediment lobes. Let's just get an idea for the scale. See how wide this is. 10 miles wide. That's a 10-mile wide sediment lobe. Right, so that was pushed from this direction. So imagine a current pushing sediment this direction, and this is the steep face of it. Okay, and in this area is mounds, which are a strictly fluvial forming feature. So we get a current direction pushing this way, and these could be sediment lobes, but they also kind of look like ripples, so it's hard to tell. But if these were ripples, the wavelength is insane. 3 miles. And on this one, 6. Or these could possibly be parallel path features of parallel streams of current coming through them. But if these were ripples, it would make sense with this river scour, because that'd be the same direction. It'd be perpendicular to the scour. Okay, let's go to another spot. This is India, and this is Pakistan. And this is the Indus River Valley, which is a mega stream, or it was a mega stream. And this here also used to be a mega stream here. The current came down through here before it went to the ocean. And right across, perpendicular to that mega stream, it's one of the best sets of corrugated ripples in the world. Let's check the wavelength. 2.7 miles. Pretty decent. And very, very consistent. And they're also perpendicular to sediment lobes. Right, these are all sediment lobes here. You can see that pointed feature. So the current went this way, went up through there. All of these, this whole landscape is all sediment lobes. And this is not a feature of wind. Wind can move sediment lobes, but it doesn't create them. And that's an important distinction, because the wind can move something off of a slip face, but it can't create these features. These are all streamlined and fluvial features here. Right, look at this. Takes a lot of work to make something this large and shaped like this. And when we keep going, we see that there were sediment lobes streamlined this direction, as if there was a current going the opposite direction of the river of the Indus, or the Indus River. And on the banks, we find megascale ripples. These are 1 mile in wavelength. And then we find much smaller ripples right next to them. These are about 0.2 miles in wavelength. And they've got a nice corrugated pattern to them where the trough dug this out. And now they have lakes. And it looks like there's salt in these lakes as well. And more of these features. You can see where the ripples kind of blend into sediment lobes. Right, that's important to understand how these features blend, because ripples blend with sediment lobes, and then you've got drumlins getting interfering with these landscapes as well. Now we kind of have more of a drumlin shape. The more they get streamlined and straightened out. So there's a lot going on these landscapes. And these right here are streamlined into drumlins. You could call them drumlins. But they're definitely more of very pointed sediment lobes. And of course, there's ripples on these formations. Okay, now we're going to go to China. This is quite the spot here. A basin with a nice patch of sand. Let's see if there's anything cool in the sand. Well, we notice a ripple pattern. Let's get a wavelength measurement from crest to crest. It's 2.4. And we also get circular troughs. And we also get salt. So check, check, check. Quite the spot. So the difference between wind and water is that water is a heavy fluid and wind is a very light fluid. So only a heavy fluid has the power to dig out these troughs. And that's from the undulating force of the water flow. Okay. And let's come down here and check out these ripples. Gosh, these are nice ones. Those are nice ripples. And they also have troughs. Let's get a measurement on these guys. 2.2. Not too bad. What does that look like? Salt? Huh. Must have been a glacier. Just kidding. Okay. And then I really like these drumlins here. These are really nice drumlins. Gotta appreciate good drumlins when you run across them. Okay. So because these are drumlins here coming down this way, these are made from parallel paths of water. And then the current, and that's somewhat perpendicular to these ripples here. Okay. All right. We've got Chad and Saudi Arabia left. We'll save. Nah, I guess we'll just do it now. Let's try this. So obviously we can just see that there's ripples here. The lake makes it really obvious to see the ripples pop out on them. Let's get a nice measurement on them. 1.5. That's a nice jog. It's a real nice jog. And so this spot is so cool because you've got the ripples and then perpendicular to that, you can see these sediment, these straight paths. It's kind of hard to see here. Let me see if I can find it. Here's a good one. So these are the straight paths. Here's drumlin paths. You have to zoom out to see them better. You see those parallel paths. These are straight paths. And then perpendicular are the ripples. One mile, not bad. And yeah, this spot is just textbook. If they had it in the textbook, obviously they don't. A lot of salt pans, a lot of corrugated forms. All these lakes prove intense trough digging, just like what we saw in Hawaii. That's the force we're talking about. This is the trough digger right here, the undulating force. Okay, so that's what's digging all of these troughs, because these are all ripples. Okay. All right, now let's go to Saudi Arabia. Also a great place for ripples. And a great place for salt pans. I mean, these ripples are quite spectacular. And there's a lot of fluvial features. Uh-oh. It's a good movie. And then also you've got accretion ridges, which is a feature made by rivers and oceans, right? So here's some accretion ridges. These lines here, that's a river bar deposit. Here's a good one. See all these lines here? These are natural formations of accretion ridges. So yeah, these are all fluvial features. Nice curve to that accretion ridge set, where they're kind of more tight here and thicker here, and then they kind of spread out. They're almost like drumlins, but they're accretion ridges formed a little bit differently. Oh, these are some nice accretion ridges. Look at how they're kind of braided on top of each other. Yeah, those are real cool. So that's a huge supporting piece of evidence to support that these are actually ripples. And not just ripples, but ripples made by the ocean. That's why they're all salt pans. And this U shape right here, ripples tend to have U shapes on them because that's kind of a cataract-like formation. You can find this in ripples in the river. Okay, so guys, hope you guys enjoyed this video and found it interesting. Please like and subscribe. Share it to your friends to so that they can learn. And I hope you guys can check out Google Earth for yourselves and be able to find some cool stuff. Oh man, look at these mounds. Those are super cool. See, look at how easy it is to find cool stuff once you understand some things. Dang, look at these mounds. Alright, let's check wavelength.